Hello friends, myself V.V. Gonkar, Assistant Professor Science of Technology in Chilkare. Today in this video I am going to discuss about partial differentiation. So before that, first we'll see the difference between partial derivative and ordinary differentiation. So in case of ordinary differentiation, we are coming across only one dependent variable and one independent variable. For example, velocity. In case of velocity, we can observe the definition of velocity is like this: the rate of change of displacement with time. So there are only two variables, one is dependent, another one is independent variable. But in case of partial derivative, we are coming across one dependent variable and more than two independent variables. So this is the basic difference between ordinary differentiation and partial differentiation. For example, if I consider area of rectangle which is equal to length into breadth. So here we can see the area of rectangle depends upon two variables. The first one is length and second one is the breadth. So let us see the definition of partial derivative. So let us consider z is function of x and y. Then here if we keep y as constant, definitely here there are two variables. If I take this y as constant, obviously x varies. Then x varies, then what happens? This z becomes function of x only. If I take this as constant, obviously this x varies and z becomes function of x only. Then the derivative of z with respect to x, taking this y as constant, is called as partial derivative of z with respect to x. Once again I will tell you, derivative of z partially with respect to x, taking this y as constant, is called as partial derivative of z with respect to x. And vice versa. Similarly, derivative of z with respect to y, taking x as constant, is called the partial derivative of y z with respect to y. And it is denoted by, this is dou z upon dou x, that is z with respect to x, taking y as constant. Here dou z upon dou y, derivative of z with respect to y, taking x as constant. So let us see some partial derivative of higher order. So how to find the partial derivative of higher order? If I want to find dou square z upon dou x square, so what I do? First I will find dou z upon dou x. Then again I will differentiate this one with respect to x. Then I will get dou square z upon dou x square. Similarly for dou square z upon dou y square. Then if I want to find dou square z upon dou x into dou y, let us see here carefully, dou square z upon dou x into dou y. Then first what I have to do is, first I have to find dou z upon dou y. Then I will differentiate this one partially with respect to x. Then I will get dou square z upon dou x into dou y. Similarly, if I want to find dou square z upon dou y into dou x, then what I have to do? First I have to find here dou z upon dou a. Then I have to go for dou y upon dou y, means I have to differentiate this dou z upon dou x partially with respect to y. Even though we can symbolically denote this one as z double x, it indicates differentiation of z with respect to x twice. This is what z xy. This is nothing but dou square z upon dou x into dou y, and this one is z of y. So let us see some example based on partial derivative. So let us take some example. If u is equal to x cube minus 3x y square, then find dou square u upon dou x square plus dou square u upon dou y square. So the question is like this: we have to find dou square u upon dou x square and dou square u upon dou y square. So given u is equal to x cube minus 3x y square. So this is what here given. So first what I do, I will differentiate this u with respect to x partially. So dou u upon dou x. So if I want to differentiate with respect to x partially, obviously this y become constant. So derivative of x cube is nothing but 3x square minus, here 3 is constant, y square is constant. So remaining is here what? X. Derivative of x with respect to x is 1. This is the first derivative. So again I will go for one more derivative, dou square u upon dou x square. So again I will differentiate this one partially with respect to x. So then 3 is constant here, derivative of x square is 2x, so this becomes 6 into x. Here 3 is constant and y square is constant, derivative of this constant is 0. So this implies 6 into 8. So I will take this one as some equation number 2. So again I will go for this one, that is dou square u upon dou y square. So now I will differentiate this u partially with respect to y. So it becomes dou u upon dou y. So differentiating u partially with respect to y, then x becomes constant. Here x is constant, derivative of constant is what? 0. Derivative of constant is 0. Here 3 is constant, x is constant. So I will write as it is. Derivative of y square with respect to y is what? 2 into 1. So this is dou u upon dou y is equal to minus 6xy. So I go for one more derivative, that is dou square u upon dou y square. So I go for second order derivative. So again I am differentiating this dou u upon dou y partially with respect to y. X become constant. So minus 6 is constant, x is constant, derivative of y with respect to y is 1. So this implies minus 6 into x. Therefore, from 2 and 3, so I will add equation number 2 and 3. 2 plus 3. Adding equation number 2 and 3. So here equation number 2 is what? LHS is dou square u upon dou x square plus RHS is here dou square u upon dou y square. This is equal to, here dou square upon dou y square is 6 into x. So this one minus 6x, which is equal to 0. Therefore dou square u upon dou x square plus dou square u upon dou y square is equal to 0. So this is our required answer. So let us see some more example. Question number 2. If u is equal to e to the power of ax into sin by, then verify dou square u upon dou x into dou y, which is equal to dou square u upon dou y into dou x. So you have to verify this one. So given here solution, given u is equal to e to the power of ax into sin by. So I will take this one as some equation number 1. So here I have to verify this result. Let us see here. To find dou square u upon dou x into dou y, first what I do, I will find dou u upon dou y, then I will differentiate dou u upon dou y with respect to x partial. So let us find dou u upon dou y. That is differentiating this u partially with respect to y, taking x as constant. So this implies here e is constant, a is constant and x is constant. I will write e raised to ax. Then derivative of sin by is cos b into y. Derivative of b into y is here b. So this is what? Dou u upon dou y. Now what I do? So I will differentiate dou u upon dou y with respect to x. With respect to x. So this become dou x, dou upon dou x, b e to the power of ax cos b into y. So this become dou square u upon dou x into dou y. So now I will differentiate this one partially with respect to x, taking y as constant. Here b is constant, this cos b into y is constant. Derivative of e raised to x with respect to x is, we know that derivative of e raised to x is e raised to x into t. So this implies a into b into e raised to x cos b into y. So I will take this one as some equation number 2. So again I will differentiate this equation partially with respect to x first, then with respect to y. That is dou u upon dou x. Now I will differentiate this equation number 1 partially with respect to x. Sin by becomes constant here. So I will write sin b into y. Then derivative of e raised to x with respect to x is e raised to x into t. So therefore dou of dou y. Now I will differentiate with dou square u upon dou y into x like this. Dou of dou y, dou u upon dou x. So here also dou of dou y of sin by a e to the power of a into x. So this is dou square u upon dou y into dou x, which is equal to, now I will differentiate this one with respect to y, taking x as constant. Here a is constant, e to the power of ax is constant, derivative of this sin by y is cos by into b. So therefore dou square u upon dou y into dou x is equal to a into b e to the power of ax cos by. So I will take this one as some equation number 3. So we can see here from equation number 2 and equation number 3 we can conclude from equation number 2 and equation number 3 we can conclude dou square u upon dou x into dou y is equal to dou square u upon dou y into dou x. So the result is what here verified. So let us see one more example. If u is equal to if equation example number 3, if z is equal to log of x square plus y square, then verify dou square z upon dou x into dou y is equal to dou square z upon dou y into dou x. So let us see this example. Solution. Given here, given z is equal to log of x square plus y square. So first I will differentiate to verify this result. First I will differentiate z with respect to y. Dou z upon dou y. Dou z upon dou y. We know that derivative of log is 1 upon x or 1 upon y. Then here log is removed. Remaining is here x square plus y square. X square is constant. The derivative of x square is 0 and derivative of y square is 2 into 1. So then I will go for, I will differentiate this dou z upon dou y partial with respect to x. Dou y, dou x of dou z upon dou y. This is dou by dou x of 2 into y upon x square plus y square. So this becomes dou square z upon dou x into dou y. Here you can see this 2y is constant. 2y is constant. Remaining is here dou of dou x 1 upon x square plus y square. So this implies dou square z upon dou x into dou y is equal to, so now we have to differentiate this 1 upon x square plus y square with respect to x, taking y as constant. So it is in the form of 1 upon x. We know that. So first I will write this 2y as it is. Derivative of 1 upon x is minus 1 upon x square. Then derivative of x square plus y square is constant, that is 0, and derivative of x square is 2 into x. Therefore dou square z upon dou x into dou y is equal to minus 4xy upon x square plus y square whole square. I will take this one as some equation number 2. So now to find this result, dou square z upon dou y into dou x, first I will differentiate z with respect to x partially. So I will write here differentiate z with respect to x. Differentiate equation number 1 partially with respect to x. So this becomes dou z upon dou x. Dou z upon dou x. The derivative of log is what? 1 upon x. Derivative of log is 1 upon x. Now x square plus y square is remaining here. Derivative of y square is 0. Derivative of x square is 2 into x. Therefore dou z upon dou x, I will differentiate this dou z upon dou x with respect to y. With respect to y. This implies dou of dou y 2x upon x square plus y square. That is, here 2x is constant, dou of dou y 1 upon x square plus y square. Therefore, so this is dou square z upon dou y into dou x. Therefore, dou square z upon dou y into dou x is equal to 2x is constant. So again it is in the form of 1 upon x. Derivative of 1 upon, that is 1 upon y, is minus 1 upon x square plus y square whole square into derivative of x square plus y square is, here we are differentiating partially with respect to y, therefore x becomes constant. So this is what? 2 into y. Therefore dou square z upon dou y into dou x is equal to minus 4xy upon x square plus y square whole square. So I will take this one as some equation number 3. So we can see here from equation number 2 and equation number 3, so therefore from 2 and 3, we can see dou square z upon dou x into dou y is equal to dou square z upon dou y into dou x. So the result is here verified. So in this video we have seen the definition of partial differentiation, then how to find the definition of higher order derivative, then you have solved some example based on partial differentiation. Thank you.